All right, so looking at an over or under estimation of Riemann sum. So I'm going to go right to it. It depends upon if your function's increasing or decreasing. So if it's an increasing function, if you take a look, when we draw a left sum, that means that these segments are touching on the left side. You'll see this underneath the curve, so it's an underestimate. While a right sum, you can see when our segments are touching on the right side of the curve, it's above the curve, so it's an overestimate. Decreasing is going to flip that the other way around. Look at the left sum. If our function's going down, the blue is our function, right? And so if our rectangles are touching on the left, then it's going to be an overestimate compared to if they're touching on the right, it's going to be an underestimate. So if I'm looking at this one, we got to order this from least to greatest. So let's start with our left sum. If we have a left sum, if I were to draw segments touching on the left, you would see that it's underneath. So the left sum is going to be the least. Then what's going to be, the actual area is always going to be in the middle. And then for our right sum, these segments will be touching on the right. And so that's going to be an over approximation. That's going to be above the curve. So that's an over approximation. Over here on this one, the left sum, I'll just start with the left. If we're touching on the left, you can see because it's decreasing that that's going to be an over approximation. So actually that's going to be the greatest than the actual area. And then the right sum will be underneath, which makes it the least. Because if you see if they touch on the right, that's underneath. So that's going to be our least because we're ordering from least to greatest. So this function, if you're given a table, if you're given an algebraic function, all you got to do is look at the outputs and figure out, hey, is it going up or down? If it's the actual algebraic function, you would do a first derivative test because that can tell us if a function is increasing or decreasing. But here we can see that our outputs, starting from left to right, are going down. So that being said, a left sum would be an over approximation, meaning the right sum will be the under in the actual area. And then our left sum will be the greatest because it's an over approximation. Over here you can see the output values. If you look at these, they are going up. So since our function is going up, a left sum is now underneath. So that'll be the least. And the actual area, and then the right sum will be an over approximation.